All right, so today we're going to be completing the Unit 2 test study guide, which is on linear functions and inequalities. So I'm only going to be going through half the problems, and then you're going to go back and complete the other half on your own. So starting with topic 1, we're talking about relations and functions, and we're going to identify the domain and range and determine whether it is a function or not. So looking at number 1, we're given a set of ordered pairs. So remember, the domain is my x values. So when I write the domain, I'm going to use my squiggly brackets to make a list, and then I'm going to list them from smallest to largest. So -6, -2, 0, and 5. All right, then my range is my y values. So I'm also going to use squiggly brackets, and I'm going to write those smallest to largest. All right, remember we're making a list, so our 4 is repeated twice, but I'm only going to write it once because we're making a list of things and I'm not going to repeat things in my list. And then to tell if it's a function or not, I need to see if my x values repeat, which they do not, so yes, this is a function. All right, number 2, we're looking at a table. So first, I'm going to make a list for my domain and range. So domain is my x values. So I'm going to use my squiggly brackets and go smallest to largest. All right, here my x value was repeated, but I only wrote it once in my domain list. And then range, we do the same thing, smallest to largest. And then to determine whether it's a function or not, I got to see if my x values repeat, which they do. -3 is used twice, so this is not a function. All right, number 4, I'm going to skip 3, so you'll do that one later. Number 4, we're given a graph, and I have to find my domain and my range and tell if it's a function. So I'm going to go through and mark every x value that there is a point. So this would be -3, -2, 2, and 4. And then I'm going to do the same thing for range. So this is 1, 2, 3, 4, 5, -5, -3, -1, 0, and 1, 2, 3, 4, 5, 6. And then for a graph, we use the vertical line test to see if it would pass. Like, we're going to use the vertical line test to tell if it is a function or not. So I'm going to take my pencil, or in my case, a ruler, and I'm going to scan it across the graph, and if any of those dots hit my ruler at the same spot, then this would not be a function. I'm actually going to do a different color so that you can see. So I have 2 points hitting right there, so this would not be a function. Number 5, we're giving a mapping. So for my domain, that's my x values, and they already have them listed from smallest to largest for you. Then range is my y values. And then on a mapping, to tell if it's a function, you don't want something having 2 arrows coming out of it, because that means that you're using it twice. So this would not be a function because this 9 goes to 4 and to 5. All right, number 7. So this domain is not going to be a list of numbers. Okay, we're going to be using interval notation to write the domain and range here. So remember, if we have 2 arrows, okay, that means that my domain is going to be all real numbers. Okay, if they're both pointing up, down, or one's pointing up and one's pointing down. All right, my range is my y values, which is this axis right here. So as you can tell, my graph turns at this point, and it's never going to come back up because my arrow is pointing towards the bottom. So that is at a +4. Okay, so my range is actually going to go from -infinity to +4. And it actually touches it actually touches +4, so I'm going to be using a bracket. And then if I were to do the vertical line test on this function, it would pass. So this would be a function. All right, so that's all I'm going to do from topic 1. If you, I would like for you to do the rest of them on your own before looking at the answer key, because it's going to be really good practice for your test, which is tomorrow. All right, looking at topic 2, we're talking about real world graphs. So I am giving you a scenario, and I want you to choose between the 2 graph options that they have. So number 10, Karina is riding a horse on a carousel. Which best describes her distance from the center of the ride in a single rotation? All right, so she's on a carousel. Let's say she's sitting here, and then here's the center. So that's the distance, okay? So as the carousel spins, is her distance from the middle going to change? Okay, no, it's not. Okay, her seat's not going to get up and move closer to the middle or move right at the middle. The seat's going to stay the same, and the center point stays the same. So we're going to be choosing graph B because her distance from the center is going to stay the whole time. It's going to stay the same distance the whole time that she's on that carousel. All right, let's do one more. A cup of hot coffee cools down until it reaches room temperature. Which graph best represents the temperature of the coffee? Okay, so it cools down until it reaches room temperature. So looking at graph A, okay, your cup of coffee has a temperature, then it suddenly drops, and then it levels out, okay? That probably won't happen unless you're putting like a piece of ice or something in that coffee. But here, the coffee is gradually getting less hot, and then it reaches room temp, so then it levels out. So this one is also going to be graph B. And I'm going to leave number 12 for you to do on your own. Looking at topic 3, we are graphing functions using tables. So they give us the x values, and we have to find the y values. So we're going to be doing number 14 because there's a fraction, and I know how y'all feel about fractions. So we have y equals 3 over 2x minus 1. So I'm going to be taking these x values and plugging them in for x in my calculator. So it's going to look like this when you plug it in. Okay, so when you type that in your calculator, you should get -4. All right, then you're going to go in and you're going to put a 0 in there. And when you do that, you should get -1. Then you're going to go through and you're going to put a 2 in there. And that should give you 2. And then you're going to go in and put a 4 in there. And that should give you 5. So now that we have our XY table, we can plot these points on the graph. So -2, -4. I'm going to go left 2, down 4. 0, -1. I'm going to go down 1. 2, 2, over 2, up 2. And then 4, 5, I'm going to go over 4, up 5. So this would be our graph. All right, so you're going to go back and do 13 later. Now looking at the next part, okay, they want you to find the range and they give you the domain. So we're going to do 15. So remember, we're making our own XY table. I'm going to put the domain that they gave us, and I'm going to plug those numbers in for x in my function. So when you type it in, it should be 3 over 4, parentheses, negative 12 plus 17. Okay, when you type that in, you should get 8. Then you're going to do negative 4. And that should give you 14. And then you're going to do 8, which should give you 23. So then our range will be 8, 14, and 23. Okay, and that's all you have to do for those. You're just finding the y values that go with those x values. All right, topic 4 is function notation. The first thing I want you to do, if it's not already, cross off 19 and 21 and the h function. Okay, those are absolute value functions, but we're going to talk about those later in the semester. All right, so looking at 17, we have f of 6. So I'm going to be using my f function because that is the name of the function in the problem. So I have f of x equals 5x minus 20. Then I'm going to go through and find f of 6, which means wherever there's an x, I'm going to replace it for the number 6. So once you replace it, you are able to type that in your calculator exactly like you wrote it down, parentheses and everything. So when you type that in your calculator, you should get a positive 10. All right, number 20, g of 7 minus 15. So I'm going to be using the g function this time. Which is an x squared plus 5x minus 11. Okay, and the first thing I'm going to do is find g of 7. So wherever there is an x, I'm going to replace it with a 7. Then I'm going to take this and I'm going to plug it in my calculator just like I wrote it down. So let me type that in. And that gives me 73. So now that I have g of 7, I'm going to plug it in. And then they want us to subtract 15 from that. So 73 minus 15 gives us 58. All right, we're going to skip down to 23. So this time they give us the function, and then they say if f of x equals negative 19, find x. So what you're going to do is you're going to take this negative 19 and you're going to substitute it in for f of x. And then you're just going to solve this for x like you would any other equation. So we want to get our letters onto the left side, so I'm going to add 3x to both sides. 3x and 19 are not like terms because 19 doesn't have an x, so I'm just going to put them beside each other. Now I need to get all my regular numbers on the right side, so I'm going to add 19 to both sides. And then I'm going to divide by 3. So x equals 8. All right, and then we're going to look at a graph example. So find f of -6. So I'm going to find -6 on the x-axis. Which is this line right here. And then I want to find what y value, what y value it hits at, okay, on that x value, which is right here at the top, which is a +7. All right, 27, if f of x equals -5, what is x? So then this time I do the opposite. I'm going to find -5 on the y-axis. Okay, and I want to see at what x value does it hit at, which would be a +2. All right, so that's all for evaluating functions. Any ones that I did not do, make sure you go back and complete those. All right, next topic is talking about zeros. So go ahead and scratch out, if it's not already, 34 and 35. So for the graph ones, you're just looking at a graph. So we're going to do 30 and figure out where it hits the x-axis, which is the horizontal axis on a coordinate plane. So here we have 2 zeros. It hits there and it hits there. So this has an x value of -1, and that has an x value of +3. So when I write it, I'm going to write it as a list. So I'm going to use my squiggly brackets, and I'm going to have -1, 3. All right. For 32 and 33, you're finding it algebraically. So I'll do 33 because there's a fraction. So you're going to take the function and you're going to equal it to 0. All right, so I need to get -2/3x by itself, so I'm going to add 10 to both sides. And then I need to get x by itself, so I'm going to divide both sides by 2/3, or -2/3. And when you type that in your calculator, you should get -15. Okay, so you're just taking the function that they give you, and you're setting it equal to 0, and you're solving for x. All right, the remainder of the study guide is on inequalities. So there's 8 examples, so I'm going to do 4 of them with you. So looking at 36, we have 2 parentheses x plus 3 is greater than or equal to 4 parentheses x minus 1. So remember, the first thing you have to do is get rid of the parentheses. So I'm going to distribute what's on the outside to the 2 things on the inside, and that's using multiplication. So 2 times x is 2x, and 2 times 3 is 6. All right, then the next one I do the same thing, distribute the 4 to the 2 things in parentheses using multiplication. So 4 times x is 4x, and 4 times -1 is -4. Now I need to get all of my letters on the left side. So I have to move that positive 4x to the other side. So I'm going to subtract 4x from both sides. And then I'm going to bring everything else down. And then I need to get all my regular numbers on the right. So I'm going to subtract 6. And then -4 minus 6 is -10. All right, then I need to get x by itself, so that -2 I'm going to divide. All right, remember, when you're dividing by a negative number, my inequality sign is going to flip. So I'm left with x is less than or equal to +5. So then we're going to take that and graph it on a number line. So since it's less than or equal to, that's a closed circle. And I'm going to shade to the left. All right, remember, if it's pointing to the left, that's -infinity. If it's pointing to the right, that's +infinity. So this is pointing to the left, so that's -infinity, 5 with a bracket because it's a closed circle. All right, 37. I have 5x plus 24 is greater than 2 parentheses x minus 9 minus 3x. So remember, the first thing we have to do is get rid of the parentheses. So I'm going to distribute the 2 to the two things inside the parentheses using multiplication. So 2 times x is 2x, and 2 times -9 is -18. Then I'm going to bring everything else down. Now, before I start moving stuff to other sides, I need to make sure that I don't have any like terms on either side. So on the right side, we do have like terms. We have 2x and -3x. So I'm going to combine those, and I'm going to get -1x. And now I can start moving stuff around. So I want to move all of my letters to the left. So that -1x needs to move to the other side. So I'm going to add 1x to both sides. And that gives me 6x. And then I need to move the positive 24 to the other side. So I'm going to subtract 24. Which gives me -42. And then lastly, I'm going to divide both sides by 6, so I have x is greater than -7. So on my number line, I'm going to have an open circle on -7, not -5, -7, and I'm going to shade to the right because it is greater than. If your arrow is pointing to the right, that's +infinity. If it's pointing to the left, that's -infinity. So this one's pointing to the right, so I'm going to have parentheses, -7 because it's an open circle, comma, +infinity with a parentheses. All right, let's look at some compound inequality examples. So looking at 40, I have -4x minus 11 is greater than 5, or 8x minus 7 is greater than 9. So I'm going to solve these two equations. So the first one, I'm going to start by adding 11 to both sides to get -4x by itself. And then I'm going to divide both sides by -4. We're dividing by a negative number, so my inequality sign is going to flip. So I have x is less than -4, because 16 divided by -4 is -4. All right, then the second one, 8x minus 7 is greater than 9. So I'm going to add 7 to both sides to get 8x by itself. and then I divide by 8 to get 8 by itself, or to get x by itself. So those are my two inequalities I'm going to graph. So the first one, x is less than -4, so that's an open circle on -4, and I'm going to shade to the left. And then my second one, x is greater than 2, so that's an open circle on 2, and I'm going to shade to the right. If it's pointed to the left, that's negative infinity. If it's pointed to the right, that's positive infinity. And we always start our interval notation by writing the one that's pointing to negative infinity. So this is in parentheses, negative infinity, comma, -4 with a parentheses because it's an open circle. And then the second one, parentheses 2, because it's an open circle, comma, infinity with another parentheses. All right, and then we're going to look at a AND example. So we're going to look at 43. So again, we're going to solve it first. So the first thing I have to do is move the +5 to both sides. So to do that, I'm going to subtract 5. So I'm left with 9x in the middle. -31 minus 5 is -36. And 32 minus 5 is 27. Now I have to get x by itself, so I'm going to divide all sides by 9. So -36 divided by 9 is -4, and 27 divided by 9 is 3. So now this is our inequality that we are going to graph. -4 has a less than sign, so that's an open circle. 3 has a less than sign, so that is also an open circle. So -4 has an open circle, 3 has an open circle, and then we're going to connect the dots. For our interval notation, I have my two endpoints. They both have open circles, so I'm going to have parentheses around both those numbers. All right, so that completes the video for the study guide. Whichever problems I did not go through and do, please make sure you do on your own before checking the answer key.